Ladies and gentlemen, for their last live demonstration of today, we are pleased to welcome back Roctool. Roctool's presentation will highlight innovative molding processes such as heated platens, showcasing a mix of high performance and energy savings. To talk about Roctool's heating technology, we are very pleased to welcome Mathieu, the CEO, and Edouard PHILLIPE, the Composite Business Development Manager of Roctool. Mesdames et messieurs, la démonstration sera en anglais. Si vous souhaitez avoir une traduction directe en français, n'hésitez pas à chercher un casque auprès des hôtesses. And without further ado, gentlemen, the demonstration floor is yours.
Thank you, Joanna, and good morning, everybody. We will spend about half an hour together, maybe a little less, but we appreciate your time. My name is Matt, and Edouard is here, and Hugo over there at the machine, so that we can present to you our technologies. So a few words about Roctool. Roctool, we're a heating and cooling provider. We also work on engineering for molds, all about integrating induction capabilities in your molds. But this year we're showing heated platens because some of you, some manufacturers, they want to have a hot press, let's call it, capability. But we show the flexibility of heating and cooling and also the ability to replace interchangeable aluminum inserts or steel inserts, keeping induction heating at all times on the heated platen. So this is what we will show you today. And hopefully you can see well. You have a screen there with some information. So right now we're going to start our cycle and show you what we do. But we were doing a dwell of the heating at 150 C. And we're going to show you that when you dwell, you're actually using a very little amount of energy with induction. You can keep heating for quite some time, just maintaining the temperature. What we're going to do, we're going to go from 150 on our press to 250 by induction. And for that demonstration, we have combined efforts with Saint-Gobain. Saint-Gobain, they have technology of a 3D knitting composite to create preforms. So the last few days, we've been molding this little guy here. I will just circulate the piece because it's not what we're showing. We're showing a plaque right now, but the previous days we were showing this is when you combine fibers and plastic together, so sometimes very difficult to place and inside the tool because of corners, because of issues. And here you can see directly by heating and cooling plus this 3D knitting technology, you can easily make a part net shape and also reduce the amount of waste of material because of the cutting of the woven and so on. So that's the first thing. So talking about the demonstration, as we're heating up, I'm sure that you can see already the heating going. Edouard will explain to you the system, and then we'll go back to the demonstration. Edouard?
Thank you, Matt, for this introduction. Yeah, we have the pleasure to show you a new technology developed by Roctool. It's a new standard for composite processing with high performance guaranteed. It's our Roctool Induction Dynamic Saver Technologies, our IDS solution. It's a hot plate that you can see here with the use on the standard compression machine. And we developed this solution to have a versatile technology with the interest of the induction heating to combine the possibility to use different mold on the top of this hot plate that we can heat by thermal conduction. In this live demo, we will have the pleasure to use aluminum mold, but we can also use a steel mold or nickel mold, which is very different. On this installation, we are on the side of this press machine or Roctool equipment. To use our technology, we need to have an induction generator. In this configuration, we have a DZ 50 kilowatts. So it's a dual zone generator, meaning that we have one connection for the top of the mold and second connection for the bottom of the mold to be able to manage separately the power for the heating depending the shape of the mold.
Oh, so actually, I think we started the cooling. So that's the thing. It's pretty fast compared to if you're doing that with oil heating or electrical cartridge. It takes a lot of time to bring a lot of energy, heat up everything, then cool down. So necessarily you don't do that. With the induction, you bring a lot of energy in a minimum amount of time. Then you can hold it. And then the cooling is only mainly cooling down the insert of the mold. The platen then can remain at a certain level of temperature. So as you see, we were going to 250, and right now in terms of temperature, we're already down to, I don't know.
80 degrees.
180? 170. So we're already cooling down, and you can see. So since it's going fast, and we go back to the presentation.
Sure.
Again, from Saint-Gobain that supplied this knit, you can see we 3D knitted thermoplastics in the 3 different reinforcements on the same part. So we're going to circulate this. So Saint-Gobain is a manufacturer. It's one of our customers. And they have that technology to combine with the heat cool. We thought it would be a good example to show you here being the matrix polycarbonate to reach about 250 C. And we're going to demold about 80 C. So we're going to do the ramp up. So let's finish. Sorry, I had to interfere.
Sure.
Let's go back to the system and the generator. Maybe you can a few words about this.
Yeah. So about the dedicated device to use our technology with our power equipment, which is induction generators, we need to have a cooling unit, and so it's the equipment you have on the side. We have a mold cooling unit, which is in this case a C6 equipment. This cooling unit can deliver 100 liters per minute at 20 degrees. It's connected with manifold to cool the RIDS platen and also the aluminum mold. And on the, next to the C6, we have also a W18, which is also a cooling unit used to cool some components for the generators. And to manage all the process, we have our RT21, it's our interface controller, where we manage separately the 2 generators, and we can adapt the cycle time depending the parameters of the material. And it's very easy to modify and adapt the programmation of the cycle with different heating ramp, dual time, and cooling time.
So in terms of temperature capability, we can do commodity resins, so low temperature resins or thermoset resins, all the way to very high heat thermoplastic resins. So with induction, you can go in the range of 200, 300, and 400 plus. So for the 400 plus would still be the heat platen, still the inserts. However, the engineering behind it will be a little bit different. We would need additional cooling capability, obviously, because you go to high heat. The type of inductors and the design for the platen would be designed for high heat. Here we're in what we call the medium heating, which is 250, 280 C. For a lot of people here, it's already pretty high heat when you look at some of the temperatures. But for induction heating, it's actually pretty low heat. So that's why we are using standard steel and aluminum inserts with a standard aluminum. Okay? In terms of dimension, so here it's about 600. It's ready? Oh, okay.
Yeah.
So we'll talk about dimension after. Let's open up.
We can open the mold and see the parts inside. That's consolidate. So you see in a few minutes, we are able to consolidate and transform thermoplastic composite material. So as I explained in this configuration, we use a Saint-Gobain aerospace material, which is a PC resin.
Yep. With 3 different reinforcements within the same part, which is the material that we've been showing around. So going back to dimension, here, and we can start the
Yeah, we prepare a second slot with another different material from Rainbow, which is a polyamide resin with carbon fibers.
Yeah, we're going to change world. So for that second one, we want to show UD tape, so unidirectional fiber combined with woven. and a nylon resin, so polyamide. So let's start. So going back to dimension, recently we installed a 2.5 meter by 1.5 meter induction heated platen to a customer. And we have some projects that seems to be also of larger surfaces. So it's very compatible for large surfaces and also for much smaller platen, like easy. This one here is 600 by 400. And we could do, for the show, we're doing different parts. We could do multi-cavity. So if you have a 6-minute cycle, let's say, and you have a 4-cavity, then you can do the calculation. You can really have fast cycle. And then when you need to do a new part, you just replace your aluminum insert, and you're back in business. You're making other production. So for the show, with the same platen, we've been molding some shoe soles. That was actually with the Rangbo material as well. We've been molding non-woven material to make non-woven parts, and also chopped tape to do high pressure and high temperature compression of composite. So if you wanted to do this with conventional methods, let's say if you had oil or electrical cartridges on a press, it would be very difficult to switch from one material, one temperature, one kind of mold. So this flexibility becomes quite interesting for whoever wants to speed up their production and also reduce energy consumption. A few words about energy consumption. I think in the past, maybe 10 years ago, we were not so much checking every little thing about energy consumption. I think today we are, everybody in their life. So one thing that we have noted at customers is when they don't manufacture. So a manufacturer in composite, let's say you want to make a part, everything's set up, you did your production, and you're finished. And then maybe it's the weekend. And you know Monday morning, there's some production happening. There's a customer actually visiting. Well, then on the weekend, most probably if you have oil heaters or something, everything is going to stay on. So that Monday morning, you can be ready for production. With induction, you don't have that need. You use induction when you make parts. In between, there's no need to keep everything hot. Think about if you do the calculation for any manufacturers throughout the show, how much energy they spend when they actually don't make a part. What would be that number? I think it would be a big number. So that's an interesting point to keep in mind, is how flexible induction can be for manufacturing. Okay, so what is the temperature on this next one? And
so now we restart to the second slot with a different material. We, for the moment, reach 140 degrees in 1 minute 20 seconds. And we need to reach exactly 250 degrees.
Exactly. So here at the show, we don't have the cooling capabilities that we wish we had, okay, in a plant. So it means we could grind a little bit of cycle time if we wanted to. Okay, please understand that. I'm sure you do. Second, we stop every time we make a part for the demonstration. But if we were to do in production, we would have the same cycle every time. So we would keep a dwell on the platen in between cycle and play with the cooling of the insert. We would never go back down to 70 degrees or something like that. We would keep to speed up production. Okay? So on this demonstration here, we showed two different kind of reinforcements. And what's interesting with the induction is that we drive the heat so well that the resin, obviously gets activated as a thermoplastic, and then is attracted to the surface of the tool being so hot, and the resin will cover nicely the weave or the UD to create what we call a resin-rich surface. So any manufacturer that is trying to get away from bubbles, microporosities, all the good stuff that we know we're fighting every day, with this good heating actually is a good way of getting rid of it, because you get to a temperature that will guarantee that resin viscosity that will go everywhere and gets you this surface finish.
Exactly, Matt. It's one advantage of the Roctool technology is also to have a very good replication of the texture of the mold, due to what you said, and it's why also we work about the possibility to innovate about the texture of your surface of your composite material, which is quite new because, as you see, a lot of parts it's only gloss. But we can have a very good replication and we can add value on the surface quality of the parts.
Exactly. I will just circulate this part to show the non-transformed material and really where the induction is active, where you can really see the thing, okay? Please be careful, it's carbon. I think there's many composite experts here, so you know that you have to be careful. But the point is, with our Roctool technology, we can really expand process capability. You know, every year, I've been coming to JEC for 20 years. It's my personal 20-year anniversary at the show. I can tell you one thing, we see so much in new materials coming every year, new reinforcements, new techniques, new resin, and I think with sustainability, we're going to have a lot of recycled resin now mixed in composite for thermoplastic. It's going to keep going. But if we do all this great work and then we end up in the factory with the same old machine, same old heating capability, temperature is everything. Temperature is what gets you to mold a material. So you can't spend a lot of investment on the material side and just say the process will just make it work. It doesn't work like that, especially now knowing with energy consumption will become such a big challenge. With this, we believe you can have a CO2 claim per part manufactured. And that's an interesting analysis that you could do to present to your customer and to offer some savings of CO2 per part manufactured.
At this moment, we keep the temperature at 240 degrees. So we see on the screen that we just need to have a few kilowatts per side to keep the temperature constant.
During
3 kilowatts, 4 kilowatts.
Yeah. So you see that people say, oh, Roctool, you're using a lot of energy. Wrong. We need a lot of energy equipped, installed. But as you process, it's a little bit like if you have a car, you need to drive, you have a car that can go to 200 kilometers an hour. Are you going to drive at all times to 200 kilometers an hour? No. You might, if you go on the Autobahn in Germany, but the point is, you know you've got the power and you use it when you need it. That's exactly what we do here. So the dwell, to heat up to 250 or 230, we use 100 kilowatts. Okay, so during that time, you're going to use quite some energy. And to dwell, we're using 3 kilowatts per side. So think about production. When you have in between cycles the ability with your thermocouple to drive, make sure you have the best optimized cycle for what you're actually doing based on your part, based on the size, and so on. So obviously, if the mold was much bigger, we would use more power. And again, we're not using any energy if we stop production, if we turn off everything. We don't keep, there's no oven, there's no preheating, and so on.
So now we stop the heating and we start the cooling. So you see that we stop immediately the energy consumption for the heating device. And we start to cool rapidly with so we reach in less than 50 seconds, 200 degrees.
Exactly. So a thing also about this configuration of those heated platen. Those heated platen are very robust. They have the right thickness. Sometimes we could be tempted to say, let's make a very thin shell of induction and see if we can save and so on. But we are doing production with our customers. We're not doing laboratory testing. So this needs to go on a small to medium to large machine. They will be exposed to compression. They will be exposed to different kind of materials that are tough. So our system, our induction system, is strong and robust and thick enough to take this. So that's why we need strong cooling, strong heating, durable induction system inside, and not those thin shell combined with whatever. This is why Roctool is well known, is the robustness of our solution. Again, so what temperature do we demold this material, this nylon?
80 degrees.
80 Celsius. 90 Celsius. Okay.
Yeah.
Earlier in the week, we also showed something, I don't know, about natural fibers. We've noticed that natural fibers, and there's a lot here, as soon as they're exposed too long at a hot temperature, they get dark, they get, there's like the smell is a lot going on. So we feel that we need to focus on actually the resin only, whatever is pre-impregnated. So the fact by induction we go so fast to the resin, we don't expose the natural fiber to a long time in a hot environment, would actually allow to keep the clear and nice color, whatever tone you call it, so which is quite an advantage. So we did this in polypropylene during the show. That was 2 days ago. And I will also circulate the chopped carbon. I don't know if I did already. No? But I think it's interesting. We see a lot of SMC with the chopped carbon around. It's been going on, and automotive, they like it. It looks kind of cool. And but we're like, why don't we do that in thermoplastic? I mean, polycarbonate, this is polycarbonate with carbon fiber. Actually, carbon is 100% recycled, and it can be so quickly molded. And we can get surface quality. We can do a matte finish. We don't have porosities. There's no issue. It's not a thermoset. It's issued from a recyclable versus the SMC, which is non-recyclable, not coming from recycled resin. So we feel that that could be a challenger to replace this chopped carbon effect that we see. And the mechanical properties are just absolutely phenomenal in terms of impact and durability. So we feel we're not chemists, we're not a material provider. We feel that we've got a good candidate with those materials.
So we finish the second run, and we can open the press to demo the part immediately. So we use several ply of carbon fibers and polyamide resin, and we will demo. So you can see also on this part we have a logo integrated on the surface, and you will have the pleasure to see the
this is the part we made right before you arrived, the time we demold. So same thing here, another shape. We just wanted to show that we know some of you, they make panels. They make fairly 2D parts. So because we did some deep draw or some compressed materials, but once you have a heated platen, you don't necessarily need to worry about the kind of form factor that you can have. We can just pass it around. Those are demo parts. In terms also of a power distribution, we can zone heat with our generator. So here it's one zone for the core, one zone for the bottom. But we could have on one panel also 2 zones in the bottom. So we can also be flexible in terms of heat distribution if really needed. Okay, so I think we come to an end to our demonstration, and obviously if you have questions, now is the time. We have 5 minutes.
Don't hesitate to ask your questions, ladies and gentlemen, even in French, of course. Mathieu is
Même en français. But
a question over here, gentlemen?
Yeah.
Is the mic? It's on? It's on? It's on already. Can we turn on the mics, please? Lauriane? C'est bon? Okay.
Hello?
Yes.
yes.
Okay.
Yeah.
Thank you for your demonstration. My question is, we noticed that how you heat the part and you cool it. Did you cool it with oil or something else? Is it oil? You
No.
cool, how you cool
Oh, no.
this?
No. The whole demonstration is with induction heating.
Induction.
Yeah.
And where is the heat go? You heat it,
Yeah.
and it costs energy,
Correct.
and it cool it.
Yeah.
Where is the energy gone?
It's gone.
Where?
I'm not sure. I mean, with the water, we the water is 25 degrees Celsius.
Yeah.
So gradually it cool down your aluminum inserts and it's gone. It removed
I mean, if we produce the parts one by one, you cost many energy.
No. Induction heating transfer energy very fast to a section.
Yeah.
Okay. And then as we cool down that section. So it's not building heat cycle after cycle.
Yeah.
It's keeping the same heating and cooling all the time.
So yeah, I'm interested in where are the energy gone? The heat. Yeah.
I mean, it's like anything. If you're heating something, okay, and then you cool down, the cooling removes the energy and take the calories away. That's for anything. Hot water, cold water, hot oil.
That means you cooled the part also by
here, this is a see-through of the platen where you have your heating elements, and then in the background we have our cooling elements. So we play with this.
The cooling is also in induction?
No, induction is only for heating. Induction, you cannot cool down with induction.
So for cooling, how did you cool it?
Water.
Water.
Yeah.
Oh, okay, understand.
Water.
Okay.
Just water, ambient, 25 degrees Celsius water.
Okay.
100 liter per minute.
That is.
So you have a good flow.
Okay.
And then you cool down just the section that was previously heated.
I see. Thank you.
Thank you, sir.
But I can add a comment. The hot water that we have during the cooling is
Forcément, oui.
delivered in the chiller group and with a heat exchanger, and you can use this heat to use for another application, for heat the building, for example. So we will have also a global solution about the energy saving concerning the temperature and the energy for the heat.
Yeah, the cooling unit also pulls everything, so we could maybe think about heating something else with the...
Okay, thank you very much for the passionate question. Any other questions from the audience? Okay, Mathieu, you've done a fantastic job of presenting everything. Could you just recap for me what are the key advantages of this new technology, please?
So I think with this heating technology, number one is the flexibility in terms of temperature. Okay, from ambient to 400 Celsius plus. I don't think there are many technologies that can do that. So when you know that you have customers with different materials coming to you, if you have this, you'll be able to say yes every time, which is a good thing. Number two, I would say this new induction dynamic saver is a way to have a good heat base and use aluminum inserts instead of doing the heat and cool in the mold. So it means once you have your heat base on your press, you can then have interchangeable inserts, so that becomes very flexible. And I would say number three, energy consumption. Energy consumption is critical, so especially if you do large panels, if you're thinking about doing thermoplastic, that could be a great solution compared to electrical cartridges and oil heating.
Okay, thank you. And I have one more question for you. Can you explain why you chose this demonstration today?
So I think this year we wanted to come up with this heat platen for quite some time, but we wanted to show many different materials in 3 days, and we have nothing to hide. It's difficult to come with our machine, our system, our engineering, and I want to say to Hugo, great job on the demonstration and the preparation, Anthony and the whole team, because it's easy to come up with a PowerPoint and some posters, but to come up with our gear, to make parts, recreate a little bit of a production environment. So that's why we decided to do this, so that you could get a feel on what the technology can do.
Okay, thank you so much. If there are no more questions from the audience, I would like to thank Mathieu and Edouard for your fantastic presentation and for being present with us during the 3 days of the live demonstration area. It's been really fabulous to hear and understand more about what Roctool does. Ladies and gentlemen, don't hesitate to come and continue the conversation with them here to see the materials. And also, their stand is right next to the live demo area, so you can meet the whole Roctool team. Our next demonstration is going to be taking place at 12:15 with Magnum Venus products. So don't hesitate to come back if you would like to see MVP.
Bonjour.
Otherwise, enjoy your day at the
Thank you very
Czech
much.
World Show. Thank you very much.
Thank you.